So yes, some of them say that there's a cycling universe. So the Big Bang is an event when space gets very hot and very dense and filled with particles. And that may happen again.
The history of the universe dates back to the Big Bang, an incredibly small speck of energy that exploded and expanded into the universe we inhabit today. But have you ever wondered what came before the Big Bang? Scientists have found hints suggesting the existence of another universe preceding our own. They propose that our universe might be just one in a series spanning vast time periods. This idea originates from renowned physicist Roger Penrose and has gained support from British physicist Brian Cox. Yet, is there solid evidence to back these claims or to delve further into the subject? Join us as we investigate the time before the Big Bang. Science tells us that the universe began with the Big Bang roughly 13.8 billion years ago, originating from an incredibly dense and hot speck of energy. This explosive release of minuscule units formed the first atoms, marking the dawn of creation in the observable universe. Over billions of years, the cosmos expanded into the vast expanse we perceive today. Currently, scientists have only traced evidence of the Big Bang to within fractions of a second after its occurrence. Determining the cause or what came before the Big Bang has remained a mystery. However, recent developments suggest a potential shift. Theoretical physicist and Nobel Prize winner Sir Roger Penrose proposes a theory suggesting that our universe didn't emerge from nothing, but is the result of a preceding universe. Penrose, a highly respected mathematician and physicist, has made significant contributions to the general theory of relativity and cosmology. His accolades include the Wolf Prize in Physics, shared with Stephen Hawking in 1988, and later half of the Nobel Prize in Physics in 2020 for predicting black hole formation through the general theory of relativity, establishing him as one of today's leading physicists. His theories are highly regarded in the scientific community. Thus, when he introduced his theory on the origins of the universe, it took many scientists by surprise. In his book, A Cycle of Time, Penrose proposed the conformal cyclic cosmology model, a departure from Einstein's general relativity that challenges many of Einstein's original ideas. Penrose's cosmological model deviates from widely accepted multidimensional theories, suggesting that the universe unfolds in phases rather than adhering to the commonly embraced multiversal concept. Penrose presented evidence based on concentric circles discovered in his analysis of both pre-existing and current versions of the cosmic microwave background. His observations led him to conclude that a previous universe likely existed before the Big Bang that shaped our own. In his book, he argued that the Big Bang resulted from the concluding stages of the pre-existing universe, which in its final moments contained evaporating black holes consuming all cosmic matter within their realm. He described that at the end of that universe, all matter existed within these evaporating black holes as photons outside space and time according to his theory. These photons closely resemble the initial photons observed in the first moments of the Big Bang, implying that the singularity responsible for the Big Bang is synonymous with the infinitely expanded pre-existing universe. Penrose's theory is rooted in the examination of the cosmic microwave background, which is the earliest electromagnetic radiation permeating the early stages of the universe. Known as relic radiation, the CMB is ubiquitous throughout the universe and provides vital data indicating the thermal, radioactive state of the early universe. It originated during the recombination period, when the first atoms formed, approximately 375,000 years after the Big Bang. While this may seem like a significant period in the vast expanse of the observable universe, it's relatively brief, offering a close-up snapshot of the early universe. Using radio telescopes, Penrose analyzed data from the CMB, capturing a moment when temperatures had dropped enough for protons and electrons to combine and form hydrogen atoms. In their collaborative analysis, Penrose and his co-authors identified unusual points in the cosmic microwave background data, offering fresh insights into cosmology. They proposed that these anomalies might be traces of signals or energies from evaporating supermassive black holes predating our universe. Linking these anomalies to evaporating supermassive black holes, the team recognized black holes as the only entities in the universe capable of enduring and producing an energy density comparable to the Big Bang. Penrose suggested that his examination of the cosmic microwave background provides initial evidence of a collision between supermassive black holes in a pre-existing universe, as these were the only structures powerful enough to generate gravitational wave ripples in the early stages of our universe. To support his ideas, Penrose delved into the practical implications of the second law of thermodynamics concerning the eventual state of the universe. While much of his work aligns with current views in theoretical physics, Penrose diverges from Stephen Hawking's assertion that information is lost once matter or energy enters a black hole. Interestingly, Penrose is not alone in challenging the idea that black holes are simply cosmic voids consuming energy in the universe. Instead, he proposes that black holes convert energy into photons that exist beyond space and time, beyond the event horizon. According to Penrose, these photons, existing beyond conventional spacetime, could serve as the fundamental building blocks for a subsequent universe, manifesting as the Big Bang event. Furthermore, Penrose argues that over incredibly vast stretches of time, potentially trillions of years, all matter in the observable universe breaks down into photon energy within a cold, expanded universe. He terms this period, stretching from the Big Bang to the infinite expansion of the universe, as an eon. The infinite expansion and eventual oblivion of the previous eon become the foundational elements for the Big Bang state of the next eon. During this critical juncture between the end of one era and the beginning of another, considerations of space and time become less relevant, making the inception of the new era seem insignificant from the observer's standpoint. Penrose suggests that the singularity presumed to have existed during the Big Bang isn't as perplexing as once believed. He argues that similar singularities might exist at the event horizon of black holes. According to him, the circular patterns observed on the cosmic microwave background are comprised of highly redshifted photons originating from black holes in the previous universe, now entering our current universe. While these circular streaks on the CMB might not appear significant to the average person, they carry low energy from a previous universe, which holds importance for physicists. Penrose proposes that cosmic energy absorbed by black holes in the prior universe could be linked to the future Big Bang of the next era. After an immense period of cosmic expansion, Penrose's theory suggesting that the universe's end will stem from an infinite expansion not only aligns with the concept of a previous universe, but also directly contradicts one of the prevailing theories regarding the universe's fate, the Big Crunch. Until recently, cosmologists proposed that the ongoing expansion of the universe signaled it was in the middle stages of its lifespan. They theorized that as the universe aged, the gravitational pull of matter scattered throughout it would eventually slow down the expansion and begin pulling everything closer together. The Big Crunch theory posited that the universe's ultimate destiny would be dictated by gravitational forces exerted by every mass in the cosmos. This process would lead to contraction, culminating in the colossal collapse of the universe on a cosmic scale. The resulting crunch would be immensely dense and hot, potentially triggering another Big Bang and initiating a new universe. While the idea of one universe's end leading to the birth of another aligns with Penrose's theory, it overlooks a crucial detail. Contrary to expectations, the expansion of the universe isn't slowing down. Current astronomical observations indicate that not only is the universe's expansion rate not decelerating, but it's actually accelerating at an increasing pace. Observations show that distant stars and galaxies are moving away from Earth's telescopes at an ever-increasing speed. This conclusion was further reinforced by the study of supernovas, where the speed of their light travel provided evidence that the universe isn't expanding at a constant rate as previously believed. This rapid expansion challenges the Big Crunch theory, as gravity appears to have little to no effect on the universe's expansion, let alone causing it to collapse. It supports Penrose's assertion that the universe will continue to expand indefinitely, eventually leading to the breakdown of even black holes into photons, thus sparking the birth of a new universe and the commencement of another era. While still a topic of debate in the scientific community, Penrose introduced a controversial idea involving extraterrestrial life, not just within our assumed universe, but in the one preceding ours. Penrose proposed the Fermi paradox, an improbable theory lacking evidence, but supporting the existence of extraterrestrial civilizations. With cyclic cosmology and the notion of a pre-existing universe, Penrose suggests that information transfer from one eon to another is feasible through his observation of the CMB. He theorizes that advanced civilizations could encode intelligence signals in gravitational wave functions, transcending universes and passing information to other civilizations in the next universe. This concept has ignited debates in the scientific community, with other researchers examining the cosmic microwave background in search of this alleged evidence. It remains uncertain whether they will reach the same conclusion as Penrose, but one thing is clear: he has captured the scientific community's attention, prompting them to scrutinize the CMB for similar clues. Whether a universe existed before ours, or if there are traces of transitional information waiting to be discovered, is yet to be proven. What is certain is that we have our own universe to explore and comprehend before delving into the idea of a past universe. What are your thoughts on this? Tell us in the comments below and subscribe for more.